Water is practically the essence of life, and humankind has been reliant on water for the simplest of reasons to the most elaborate of uses. Over time, the dependency on surface water resources has been taxing on Mother Earth, and slowly, due to development and exploitation, a global water crisis has been looming. There is, however, another viable alternative to surface water resources, and it may offer a practical solution for the supply of fresh water. Groundwater resources have the capability of addressing the water crisis, particularly for remote areas and close to the sea, where access to surface water sources may be economically and physically unfeasible. Realizing that a comprehensive action plan would be needed to tackle this critical issue, the Ministry of Energy and Natural Resources embarked on a project to fully realize the potential of groundwater resources in selected states within Malaysia. One such endeavor is the Hydrogeology Mapping and Development of Groundwater Resources, or PAT project in the state of Perak. Spearheaded by the Department of Mineral and Geoscience Malaysia Perak under the activity of hydrogeology of the Geoscience Unit, this project outlines the necessary strategies and steps in ensuring clean fresh water supply from groundwater resources in identified affected areas. This is the story of that journey. As development and repurposing of natural resources expand over time, surface water sources have been depleting, while demand for treated fresh water has been steadily increasing. While Malaysia is blessed with an abundance of water resources, there are still some areas within the nation that have faced difficulties in accessibility to uninterrupted fresh water supply gleaned from surface water resources.
We do need to be prepared and not be overly dependent on surface water resources. We have seen disruptions to water supply due to contamination of our surface water resources. While we try to educate the nation in understanding the need to conserve and preserve water consumption, we need a contingency plan if and when we are faced with a large-scale water crisis.
Given the fact that in the year 2017, Malaysia has approximately 5 trillion cubic meters of groundwater resources, it makes perfect sense to delve into this alternate source of water supply. While the development of groundwater resources may never supplant surface water resources, it can very well be a supplement to the main water supply, especially in certain areas where the supply of water from surface resources may be terminable and problematic.
Groundwater is less susceptible to contamination by pollutants unlike surface water resource. Coupled with the fact that there are areas here in Perak that is having inadequate or unreliable surface water resource, it is high time that the groundwater resources to be fully tapped.
Groundwater resources are a feasible alternative water supply source in remote areas, localities where there are no treated water supply, areas with frequent water disruptions, new settlement areas, and areas which are prone to peat fires. Groundwater is also suitable as a stopgap supply during emergencies and may be utilized for agriculture, aquaculture, and industrial purposes. Groundwater resources can be developed at a relatively lower cost than surface water resources, especially when developed in a strategic and localized small scale. It is with this aim in mind, the Department of Mineral and Geoscience Malaysia embarked on a strategic action plan to be focused in the state of Perak, particularly within the district of Bagan Dato, where the perennial issues of low water pressure and peak time water shortages have become a bane that needed both intervention and sustained mitigation. Addressing the issue at hand and identifying the problem as well as the panacea, the Department of Mineral and Geoscience Malaysia drafted the Hydrogeology Mapping and Development of Groundwater Resources in Perak proposal, tabled and subsequently approved with a project budget of 12.5 million ringgit under the 11th Malaysia Plan. This project is part of and a sub-project of the National Groundwater Resources Study Project under the auspices of the Ministry of Energy and Natural Resources. The overarching objective of this project is two-pronged, where it was the intention to innovatively provide immediate clean water supply to problematic areas, especially within Bagan Dato', and subsequently update the National Groundwater Resource Inventory as a means of perpetual monitoring and controlling measures at the federal level. The hydrogeology activities under the Geoscience Unit at the Department of Mineral and Geoscience Malaysia Perak was tasked with the planning, scheduling, execution and completion of this project. The scope of the project entailed hydrogeology mapping studies in establishing baseline parameters and the hydrogeological properties of groundwater aquifer systems within the identified problem areas of Bagan Dato', Brungkop, Seleko, Teluk Baru and Hutan Melintang in the state of Perak, incorporating geophysical approaches in determining groundwater potential in the Bagan Dato' district, developing potential groundwater resources within the identified areas through the construction of deep tube wells, infusing the use of project management practices as well as information and communication technology ICT to establish effective hydrogeological mapping data storage, management and processing systems, establishing sufficient and state-of-the-art geophysical and field equipment, including the upgrading and upkeep of tools and drilling machinery. Knowledge and expertise exchange between the Department of Mineral and Geoscience and the Perak Water Board LAP, as well as other relevant national water management authorities and agencies. Armed with financial support of the government and a clear project premise, this undertaking hopes to ensure groundwater and additional water supply to new water treatment plants in Bagan Dato', increase in water pressure capacities in affected areas by virtue of water supply from deep tube wells, undisrupted clean water supply to 70,000 end users during drought seasons and peak usage during festivities.
This project utilized all the expertise of our departments in identifying affected areas, establishing both the potential and capacity of groundwater resources by way of hydrogeological measure, and more importantly, ensuring a sustained and uninterrupted supply of water to those who are in dire need.
In order to ensure the groundwater exploration meets the requirement and its standard, proper and systematic planning is a major key to execute the exploration process. The groundwork which involves the desktop fact-finding and data collection are most crucial.
We had to do in-depth research on the initial data of topography, geology, hydrogeology information, and access on facility of research area.
Groundwater exploration is a very unique process. The success in the groundwater targeting lies in experience of understanding the geological conditions, structural conditions, and hydrogeological conditions which favor the occurrence of groundwater. As it is a hidden resource, it requires techniques which classified as surface exploration and subsurface exploration methods. These methods are employed to target the groundwater potential zones. Identifying the location of its availability is a challenging task for the hydrogeologist, which requires basic understanding of its position in the subsurface geological setup. The exploration phase began with surface methods, which is to determine and gauge the potential of groundwater at a fast speed, which covers a large area with cost-saving solution. These surface explorations involve preliminary research investigation and geophysics survey. The geophysics surveys carried out in this project are two-dimension electrical resistivity and transient electromagnetic method. The two-dimension electrical resistivity involves measuring the resistivity value of soil and earth material based on potential difference measured and value of flowing electrical current, while the transient electromagnetic method measures the conductivity of differently layered materials. Once the surface methods identified that there will be an adequate quantity of good quality groundwater, the drilling process takes place. This process involves drilling method, drilling material sampling, lithological logging, and geophysical logging. In this project, the deep drilling method is used. This method can achieve hundreds of meters of depth in large diameters. This drilling using rotary methods, which is the common drilling techniques used to drill large diameter holes. The drilling technique that was used in this method are mud rotary and reverse circulation. Mud rotary uses drilling mud that lifts pieces of cut samples upwards while halting the drilling hole from collapsing and cooling the drill bit itself. This technique is best used on unconsolidated layers. On the other hand, the reverse circulation technique involves the usage of water being pumped upwards alongside the drill materials through the drilling pipe and then discharged into pits. Water and drilling mud inside the pit will then be put back into the drilling hole. Water level in the drilling hole and the pits must always be in the same level. This technique is best used on unconsolidated layers and drilling holes of large diameter. This operation requires a significant amount of water. To obtain samples that reasonably represent subsurface conditions over the entire project site, drill material samples must be gathered for each change in lithology when there is a sample change, fluid color, and time period every meter of drilling. Basic information that must be recorded are material type, color, size, and shape. Wells are designed and constructed by determining the casing and screen position, gravel, bentonite plug, and backfill quantity. Formation characteristics, aquifer type, groundwater level, water needs, approach and cost of building the well are the factors that has to take into account when designing a well. However, the final design is subject to site-specific observations made in the test hole or during the well drilling. In order to do this, the hydrogeological assessment to determine whether and where to locate a well should always be done by a knowledgeable driller or professional geologist. Well development has to be conducted after well construction is done to add features and lifespan of the well. It involves the process of extracting out foreign particles in the well using techniques such as air surging and pumping. At this stage, the placement of the screen near the desired aquifer, the function of gravel as a water filter, and the use of bentonite to prevent foreign water from entering the aquifer are vital considerations to be made. Throughout the well development, the main techniques that were used are air surging and pumping. Air surging process involves streaming compressed air into the well in an immediate swift manner to achieve a strong surging effect. This results in the foreign particles being ejected from the well until the water becomes clear and free of contaminants. Once the well is completed and developed, a good practice is to conduct a pumping test. On this purpose, the well is pumped at a constant rate, typically for 72 hours or more. At this stage, the water levels in the well are checked and recorded frequently. Pumping tests are used to determine the efficiency and capacity of the well and to provide information about the aquifer potential. Since the project was initiated in 2018 until now, PAT has successfully built and developed 12 groundwater wells comprising of exploration wells and test wells. Hydrogeological data from different sources of groundwater wells and previous studies were integrated to develop a groundwater modeling for Bagan Datuk Basin. Initially, a conceptual design was developed, followed by constructing a 3D geological and 3D hydrogeological numerical design. The groundwater modeling is a tool that can help to analyze many groundwater problems. They can be used to stimulate the behavior of complex aquifers, including the effects of irregular boundaries of fresh, brackish salt water based on geological input and safe abstraction rate. The construction of the water supply system for Bagan Datuk through the groundwater treatment plant, which has a capacity of 5 million litres a day, by the Perak Water Board LAP in 2019, has seen continuous efforts to ensure the prosperity of Bagan Datuk citizens. The innovations developed by the Department of Mineral and Geoscience Malaysia Perak, alongside the service provided by the Standard and Industrial Research Institute of Malaysia SIRIM, to supply and install the water treatment system for underground brackish water at Sekolah Menengah Sains Teluk Intan Semesti is a success in treating brackish groundwater into fresh, clean water. The Ayak Nano can supply around 5,000 litres of clean water daily to support the alternative needs of the school.
This water station really helped the student in order to overcome their water supply problem, in which they use the water for their drinking purposes, and also the dining hall use it for the cooking purposes.
By 2050, the United Nations predicts that around half the world's population will suffer from clean water scarcity. Our future and the future of the water we use are inextricably linked. Securing them both will require more than just investment. The imagination of groundwater sources that people have, the technologies that have developed in well exploration, and the will to solve this problem is something that we need to further study. What we need is awareness and a new respect for a precious resource we've taken for granted far too long. If we continuously see the opportunity to improve, we are going to move to a better place. The success story of the hydrogeological mapping and development of groundwater resources in Perak should not be the end. Yet, a huge opportunity is waiting to be expanded and explored. The journey must continue.